Hello folks, at this point I would like to introduce to you Fusion 360. This is the software I mentioned a few times where we will export our Blender models to, so we can harness the NURB surfacing features Fusion actually provides to you together with the polygonal subdivision surface modeling approach we so far explored inside Blender. The software, again, for students is free, so you should have created your uh, student account at the Autodesk Education website. And when you go to Fusion 360 autodesk.com, you can just click Try Now or Try It. And then the software, if you're Mac or PC, will download an install client. So for example, here on the Mac side, I'm opening the disk image, and then I have the installer install it, and then the software will download, or the installer will download the application for you. So let me start Fusion on my computer. The really nice part about Fusion 360 is actually it is cloud-based. That means operations, etc., are of course running on your side, but your data, etc., is stored inside your online account. So you see, actually, I do not punch in the serial number. Actually, I have to punch in my Autodesk account. So again, whatever computer the software might be installed, I can log into my account and have my files immediately accessible. So I type in my user account and my password. And then it takes a second because, of course, this is web-based. You might have to sync some data or information. And it should be finished loading. Yeah, there it's coming. Okay, so what do you see here? This is the dashboard. Looks like a web browser. You have forward, backwards, refresh, and a home, and a share button. And so here's my profile, some tabs for my home, my data groups. I'm, for example, inside, search. Here's an activity feed. For example, this is very interesting when you collaborate with other designers or engineers together. And for example, here a list of all my different objects. And if I would like to create now a new file, see there's no new file command. We don't really use actually the main menu. It's all interface based. So for example, here I just type in Power Tool, maybe version 2, and just click Create. And then Fusion will create a new window or tab. So you see there's a tab. And then you have your work environment. So a quick introduction into how to navigate it. You see here are all the different design tools. Here is a rotation tool, so you can click on those corners, or you can click, hold your mouse button and drag your mouse, for example, to rotate. You can also middle mouse button, pan around, shift middle mouse button, rotate, scroll wheel, zoom in and out. So it's very, very similar. You have 3 different design modes like Sculpt. This is actually very much like in Blender. So for example, you can see you can create a box, a plane, sphere, extrude, revolve. You, oops, hold on. You have different mesh modeling commands, for example, inside an edge, slide an edge, bevel, subdivide, bridge, thicken, like the solidify command. So you see they're actually very, very similar. And then here we have a browser, which is, for example, like the outliner in Blender. So let's go to my Blender model. And I would like to start with bringing in my handle and then maybe my battery pack. So let me go to this layer. So I only see this part. And let's take a look at what I have here. So here's my handle. And let me go to my modifier stack. So you see, for example, I created a material thickness, and then with the Boolean modifier, I cut this front part out. So kind of like I have a nice handle with the material thickness added to it. Now I mentioned before that a lot of the tools or the way how we work here will be one-to-one transferable to Fusion. So let me show you now the steps I have to do. What in this situation I actually can ignore is, for example, the solidify modifier. I don't really need this one. And for example, the Boolean modifier I can turn off, because those are commands I will redo inside Fusion. And the only reason why, for example, I showed you how to do this in here is because I can so quickly just explore some design changes very rapidly, giving up a little bit precision, but at the same time, again, when you start exploring an idea, you don't want to lose yourself in details, play through some ideas, and then later go into details. And the detailing is, for example, we're now going to do in Fusion. So this surface here, which for example cuts out the front part and the mesh for the handle, those two I would like to transfer over into Fusion. This object is using a mirror modifier, so I can, for example, if I want to turn those functions off, so I have everything turned off besides just the mirror modifier, because I would like to bring over a complete handle. So those two parts I select, then I go to File, Export, and select Wavefront OBJ. Maybe go to the desktop. And for example here, I have to turn on selection only, so I only export the mesh of objects I have selected, like my handle and that surface that cuts out the trigger part. I would like to have apply modifiers, because the mirror modifier for my handle, I would like to be applied, so I export a complete handle, not 50%. And by default, you have a scale of 1. This actually will result in an object that is 100% or 100 times smaller. So I figured out that with Fusion, if you export an OBJ mesh inside Blender, you have to put down a scale factor of 100. And for example, then I can just simply click Export OBJ. Let's go back to Fusion. And now I would like to bring that geometry into Fusion. So I have to go to Sculpt. Again, Sculpt mode is basically the polygonal modeling environment, which is very much the same like in Blender. Then I can go to Modify and go Insert Mesh. That is like to import. And there's like a small tooltip basically tells you that this way you can import OBJ or STL meshes. So I select it, and then the software will give me a dialog. Go to desktop. Here is my OBJ object. Click open. And there's now my model, as you can see. So while, for example, Blender is using a subdivision surface modifier, which I can turn on and off, for example, to switch between a boxy look and a smooth look, Fusion works in a similar way, but not exactly the same way. So if I go to bodies, for example, in bodies, it shows you all your objects inside your scene. So you see, for example, I have one object, but actually those are two separate. And this is just the mesh body. And if you right click, either, for example, on the name or on the model, or if you go to modify and convert, it gives you then a convert command. And for example, what I have here is like I can select entities, selection filter. This means I can select different object types. This is a mesh, so I have mesh body selected. And then the operation basically houses what's the end result of this convert command. I would like to have a new body. And with what new body here basically means, it will, you can see that immediately once I hit OK, it will create two new objects. So you see, for example, the front part and the trigger. And those are T-spline surfaces. And T-spline surfaces are pretty much or very similar, not the same, but they are based on subdivision surface smoothing. So you see actually that this result now is nice and soft. I still, for example, have my former polygon model inside there. If I want, for example, this one, I can now delete. I don't need it anymore. And let's, for a second, take a look at how this, for example, works. So here's a display mode. And if I, for example, turn the display mode to box display, again, that looks like the polygon model, because the T-spline is kind of like a polygon model with a built-in subdivision surface smoothing at once. But instead of setting different levels of 1, 2, 3, or 6, it is just boxy, or for example, it is soft. So you see it's really just the same. And for example, if I now would like to have something similar like the Boolean operation, so I use the surface to cut out this handle part, I have now to convert those T-spline surfaces into NURB surfaces. So I can select those two objects, right click, convert, and for example, now a T-spline object I can convert into a new body. You see that the object looks different now. And if I click OK, now see my T-spline objects, they're still there, they're just hidden, and I have two bodies. So a body, that's actually now a mathematical surface, like a NURB surface. You see that the layout or the structure is very different. So I do not have the polygon faces anymore. The surface is perfectly soft. And with polygonal modeling, I can easily select a face and extrude something out. And that is something I cannot do with NURB surfaces. But what I can do with NURB surfaces is I can, for example, like here, intersect two surfaces and then let the math code calculate how, for example, this surface intersects with other surfaces and where it intersects, think about like a scissor, we just cut everything off. So let's do this. Let's go to patch. Patch is, for example, where all the surface commands are. And for example, here is a trim tool. So with the trim tool, I can select my input surface. So this curve basically, or surface that should be used to cut this part out. And you can see when I move my mouse to different parts of my handle, the software already figured out like the different parts. So if I click it, it is red, and I click OK, you see the surface actually got removed. Now I would like this, for example, to go. So and if you zoom in, and that is the advantage of NURBS, because this is all math, basically, the cut surface, the line is super perfect and precise. For example, in Blender, based on the polygonal, and not based on the polygonal model, based on the subdivision surface level, I give the different meshes. You can see that it's very faceted because, well, it's just a polygon model. It's not really as math-based or surface-based as NURB surfacing. However, the advantage of here is this is very, very fast. So I can quickly explore styling and different variations and maybe add some details to it. So it has a different application quality. It's not very precise, but for the conceptual thinking part, it is just that fast. But for precision, not really that usable, but greatly for that, we have Fusion. So we can use both programs in tandem together. Kind of like use the right tool for the right task. Okay, so let's say I would like to close the front part. So for example, I could go with the trim tool again. For example, select my handle. And then I use the handle basically to cut the outside out. So see, I can click it. And again, the software can calculate where are those intersection lines. And based on how those two objects intersect, the software knows how to cut everything away. You see, it's still pretty much like the like working with foam. And you draw your blueprints, and then you take a knife or a bandsaw and just cut through it. Pretty much the same. So you saw actually I flipped the normal. So even with NURB surfaces, it's the same. The nice thing in Fusion, you see actually the orientation of a surface. The golden color is out inside, and the silver color is outside. And let me introduce to you, for example, now one of the key features besides this trimming, what you can do with NURBS and solids, what you can't really do with polygonal models. So I have here a command called stitch, and stitch basically means it is sewing the different surfaces together. So for example, here I have one surface, and then I can select those. So you see there are different surface patches, and they all basically share kind of like those edges and then flow nicely together. And if I select everything and then select stitch, you see, for example, here's a green line. This means there are two different shells which are stitched together. The red lines means the object is open there, so it's all okay. And I click OK. And now I have a new body. You see the body actually says I have 15 different surfaces. So if I, let's say, unstitch, okay, you see now I have all the different individual patches. So why do you have to stitch stuff? Stitching, you really need to create, how could I say that, like a logic unit. Because with everything being one object now, I can go to the model mode. And model, basically, here you work more in the mindset of working with solids. And for example, under Modify, I have a fillet tool. And because this object is joined, you see, if I move my mouse to those edges, nothing happens. While they are actually edges, the surfaces perfectly flow together. But here I have kind of like a trim edge and a sharp edge. So the software understands that here's something sharp, so I can click it. And then you get a small new dialog. For example, there is a small arrow, and just check out what happens if I click on this arrow and slightly move it inwards. Small steps, 2.5 millimeters. You see it's actually rounding that edge and interactively creating those new surfaces for me. So that's why I said, for example, in your design process, think about styling proportion in everything, but wherever you have a sharp edge or we need to have a transition, for example, the transition of the battery handle into the battery pack, those are final details you do at the end. And I can even, that's a cool part, so think about those features like the modifier stacks. They provide different input options. So you can see that afterwards, if I double click this one, it opens the dialog box. Edit fillet, right click, maybe 3 millimeter, tab, 1 millimeter, tab. So you can quickly play through some ideas. 2 millimeter tab. Okay. Whoa, I rotated my view a little bit too much. So let's maybe yeah, let's try this. Let me give you a little bit more information about some of the surfacing tools you're going to use mainly in this program. So I modeled everything so the top part and the bottom part, for example, are closed. Not closed, they're planar. So I can actually fill a surface in there. So for example, I have a patch tool here. So I can click patch, click on this ring, and it fills in a surface. Okay. And maybe right click and repeat patch. I do the same here. So why did I do this? Well, it's actually very simple. So I select everything, stitch, new object, okay. So it created like a new solid model. Think about this again. Every time when you stitch, basically you kind of like make a solid foam model, not just a surface. Because now in the model mode, there is something called shell. And for example, I can click this part. So I select like the top surface. And then maybe, let's say, 2 millimeter to the inside. It is actually shelling or shelling out my design. So basically, this is similar to the solidify modifier. And if I take a look, worked pretty well. Only problem, as you can see, this part actually is close, because that's the way how, for example, the shelling commands very often work. But what's really nice about this software is actually it takes the outside software and projects it to the inside. And for example, here we still have a nice internal flow. But for example, in the front part here, I have out in the outside a very small radius, and when it shrinks to the inside, it will get so small that at one point the radius can't be scaled down, so it will end up like into a straight line. But that's also an internal part. And if we send this to the Rapid Prototyper, that's more than sufficient. There's of course a lot more to it, but I only want you to introduce to you to some of the basic concepts and demonstrate to you some of the features you can do with the software, so you kind of like start understanding how to think with it, what tools it provides to you, and when, for example, to use which command. So for example, I can also do something similar. So maybe I actually going to, hold on, no, actually I'm keeping those two meshes, but I just would like, yeah, I do it this way. So I'm going to stitch them together so it creates one new object or a body. Okay. And then I unstitch it, click OK. You can, for example, see now that through this way, all the different features I added, for example, the fillet tool actually got turned into tangible surfaces. So think about this maybe like applying a modifier inside Blender. You just bake it like with the mirror modifier. If you have half a mesh and you apply the mirror modifier, you end up with like a solid mesh. And basically, I found out that stitching and unstitching is kind of like similar to that. You just quickly bake all the interactive elements. Because what I wanted to have is I wanted to have those surfaces I can work with. So those two, for example, I would like to hide for a moment. So they're gone. And then this, I stitch back together because I would like to have one solid shell, because now I'm creating an offset. So maybe I select the surface and distance, maybe, let's say -2 millimeters. So it creates the offset to the inside. And maybe for, oh, 2 actually was good. Okay. 4mm might be too big. Oh. You see, as simple as the shell is, there is actually a lot of math going on in the background right now. And yeah, there also I reached some configurations that are actually resulting in bad geometry. So the software will tell you that, nope, I'm not going to do this for you. But I think 2mm will work. Okay, perfect. Great. So let's take a look what we have. So for example, this is my offset surface or my solidify surface. This is my outer surface. For example, a difference you can see besides being smaller, again, see this is a sharp edge and here everything is still nicely soft and round. And a cool part is, let's show it this way, the inside and there. So like I showed my upper and lower cap. And basically now I'm going to select the trim tool. This is my trim object. And I should be able, yep, to just select the insides, remove it. So you see, kind of like I have those bridge parts there. Show the other surface. Everything lines up now. And for example, now I can select everything and just stitch it. It will take probably a second to calculate. And there it is. Now I have like a handmade handle part where also the lower part and the upper part are open. So I need it by hand to create an inner offset surface and then trim it with the cap surfaces and then join everything back together. I would like to leave it at this point. This should function basically kind of like as an introduction so you understand the methodology and the process, how you have to think about through different steps and how to build your parts, which is pretty much the same kind of like in Blender, where for example for the battery pack, like I created all those different surfaces and for example trimmed everything together. For example, I'm going to show you this one as the last step. So for example, I have all these surfaces here and I go to File, Export, Wavefront, and again Scale 100, Apply Modifier, Selection Only, Export, and then I go to Fusion, go to my Sculpt, Modify, Insert Mesh, open the drill, open. And you see also the really great part, everything is being imported into the right position. So you see the battery pack is right below the handle. So now I have to do the same song and dance again. This is a polygon mesh. And I have to give the software a subdivision surface modifier, which in Fusion is T-spline. So right click on it and say convert to new body. You see this is blue, or not blue, it's kind of like violet. That means it's a T-spline object. So you see yellow is a mesh, violet is a T-spline body, and orange is a B-wrap face, or NURB surface. Click OK. Calculates a second. And then I have all my different T-spline objects. And for example, all those I select with Shift, first and last, and select everything in between. Right click, convert. Oops, sorry, I was silly. I will just select everything as a new body. Click OK. And there I have now my NURB surfaces. The T-spline bodies, yeah, I keep for a second. Okay. So now in Blender, I actually used those surfaces to basically trim my foam block into the shape I want. And here, now I can basically do the same, but instead of using a block, I cut the surface away. I could do that. I can also simply make the surfaces cut each other. So again, what's really important is when one surface goes to another surface, it really has to go from one side straight through the other side. So it cannot stop inside. So for example, this blue surface cannot trim this surface because it's inside. However, this blue surface can easily cut this surface. Because you see, think about this one as a knife, it cuts completely through. So sometimes the order is simply important. And let me quickly show you how I'm going to process here. So I go to Patch and Trim and say, you can maybe trim this part, and this part. And it shows you and only, I think, allows you to, how does it do it? Oh, pretty awesome. Fusion properly understood how to continue the projection. So yeah. So everything that you could trim with that surface, it highlights you or makes selectable. And cut. See? Dang, everything on top is gone. Now maybe this surface, right click and trim. Let's see what I can cut. I can cut this part, this part, this part, this part. Yeah, I think this is everything. Okay, and cut. See, it's gone. Repeat trim. This side surface, for example, should be able to cut this. No, actually, it does not yet. Hold on, cancel. Trim. Ah, there. Trim, 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 and it's gone. And you right click. Trim, 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 trim. So it's like you're working with a paper model. So for example, this lower surface, should be able to trim this part, this part, this part, and this part. Okay. And then the surface, you see, it basically it touches all the side surfaces, it lies on it. So I can use it to cut all the stuff away. And you should be able to cut all this away. There. There is our battery pack and stitched together. See? That was it. So similar similar process. With NURB surfaces, it works a little bit different, but I end up actually with exactly the same design or model I developed here and inside Fusion. And that's a really great part. And then, for example, the next step, I would have to finish this one, round the edges, and then maybe try to see how I can join those parts. So for example, the offset thickness I created here, of course, at that point was a little bit silly to do, but I just wanted to demonstrate to you how to do it, because you would, of course, completely finish everything, because you have to think about later how are the different shells being manufactured or injection molded. So I have to create a geometry that is like defining like a full part which should be manufactured, and then that part, once it's done, I create the material thickness. But that's something we will cover properly like in a week or so, when we get ready to send the models to the 3D printer. Okay, well, I hope this was providing you a good understanding, and I hope that you see actually it's a different interface, but a lot of the tools are very similar. Like with the edge rounding, that is definitely something you can do with BREP or NURBS or solid geometry. But the nice sculpting of like very organic surfaces, you can use then a polygonal approach. And like with the battery pack, with using all the Boolean modifiers, this is pretty much one-to-one then creating you a good design idea how, for example, later then in your industrial design program, the surface actually also will turn out.